Welcome, guys. Yeah, so let's solve this problem. Yeah, so this problem blew out my mind. This is the thing that I never heard of. So basically, if you want to shuffle array, right? So this problem is shuffle array, and then you have an array, right? And then you have two operation. One is reset, so you reset back to your original array. And the second, you need to return a shuffle, right? And the shuffle is that all the permutation of an array should equally likely. Okay, so the difficult part is that how do you implement the shuffle? Okay, so if you go to a solution, you can think look at there's an algorithm called a Fisher-Yates. Okay, and then you can copy the code. You can copy this code to this, and then you pass it, right? But my video is that I want to rigorous or at least mathematically rigorous to prove that this Fisher-Yates shuffle is actually work when theoretically. So once you know why this works, then I think the implement is not difficult. Okay, so this algorithm is interesting that so if you want to shuffle this, right, you first choose 1 to 9, and then you randomly pick a number from 1 to 9, and then you swap this number. You swap the number you choose with the final one. Okay, so suppose in the first round, let's say I randomly choose Y, so Y swap with T, so I get this. And then the second step, I choose this yellow, right? So now I have 8 numbers, and I randomly pick one. So in this case, you randomly pick N, right? So N swap with N is still N. Okay, and the next you pick up, let's say O, so A with O, and then you randomly pick out a string, pick out a character from this 6, and swap with final one. Okay, so then they keep going, and then amazingly, this will give you all the results, all the equally likely. Okay, so I think everybody knows how to write a code, right? So this is not important. The important is that suppose you have 1 to n, let's say 1 to 2 to n. So the first step, the algorithm is that suppose you have a black box. This black box is a random number generator. So random number generate integer. Let's say you can generate from 1 to n or any 1 to m, which m is less or equal to n. Okay, so the idea is that the step is that you first choose. Let's say you choose a number x, right, from 1 to n. And then let's say you choose x, and then you can swap x with n. Okay, and the second step is that you choose, let's say you choose x from 1 to minus 1, right? Let's say so now you just forget about this, and then you choose something which is swap with this. So swap x and minus 1, and you keep going. So the final is you swap this, and you don't do anything. Okay, so this is the code. Okay, I think you can write it as a for loop, but it's not important. So our goal is to prove that why this is work. Okay. So let's work on a simple case. So in the mathematics, you can use mathematical induction, right? So let's work in 1 and 2. Suppose your starting point is 1 and 2, right? So and then your algorithm say what? Your algorithm will first randomly choose 1 to 2 and swap with 2, right? So you have the half probability to choose 1, right? If you choose 1, then it didn't change anything, right? So sorry, you will swap with the final, right? So if you choose 1, then 1 and 2 will swap, right? If you choose 2, then 2 and 2 will swap, so it's 1, 2. Right, so you can see that in n equals to 2, you randomly generate the equal probability for the first 2. Okay, so how about n equals to 3? Okay, so let's see n equals to 3. So you get 1, 2, 3, right? So the first step, you can change. If you choose 1, right? You choose 1, then it become 2, 3, 1 because 1 and 3 swap. And if you choose 2, they become 1, 3, 2, right? We swap with final. If you choose 3, then it's still fixed 1, 2, 3, right? And the next step, you only randomly choose these 2, right? So it has the probability to randomly swap the first 2. So you get the 3, 2, 1, 2, 3, 1, 3, 1, 2, 1, 3, 2, 2, 1, 3, 1, 2, 3, right? So you can see 6 of them happen. Yeah. Hopefully I didn't mess up something. Okay, so it's equal probability. Okay, so now it gives you a feeling that why this is true. Okay, so we can rigorous prove it. So my mathematical induction. I can claim that suppose so I claim that this Fisher-Yates algorithm is create equal probability. Okay, so in order to prove it, let's assume. So we need to prove the base case, right? So n equals to 2, n equals to 3 are already proved. Okay, so let's second is that I suppose this algorithm, this FY algorithm works for all so always success, right? In a let's say n-1 array, right? Okay, and I try to prove that it works for n array. So third, n array works. How this is true? So this is difficult. This is simple, right? So I think everybody knows this, already see the trick. I suppose you have this, right? So in the first step, that you will randomly pick up one, and if it's changed with final, right? So that means after the first round, right, you will generate 1 to 3 to n, right? Or if you choose n, it didn't change, right? If you choose, let's see, okay, so if you choose 1, it become n 2 3 1, right? And if you choose 2, it become n, right? And 1 and 3 and 2, right? And keep going, right? So you will see the final one is n 1 to 3 if you choose n, right? So after the first algorithm, after the first round of algorithms, it already produced exactly n arrays. The important part is their final one are all different. So actually they start from final one, or you can say that yeah, so their final one are all different, right? So that means what? That means in the second step, it will automatically randomly shuffle this, randomly shuffle this, and by our theorem, this algorithm will work for n minus case. So you will randomly shuffle this, randomly shuffle this, randomly shuffle this, randomly shuffle this, randomly shuffle with the equal probability, right? But the first step is already equal probability. So for each one is still equal probability, right? So total is that n times n minus 1 factorial, right? For each case, so it's n factorial, right? So it proves that this algorithm works, successfully generate equal probability of each permutation. Okay, so yeah, once you know this, write a code is not difficult, right? But the amazing is that this algorithms is the first time I heard it, it's very amazing that this will work. Okay, so hope you guys learned something. See you guys next videos.